As we continue with polynomial equations, in this video, we'll look at factoring out common factors in polynomials. Okay. Um, so here the outline includes the following. We talk about greatest common factor for constant numbers, greatest common factor for variables, extraction of monomial factors from a polynomial, checking factorization by distributing back, and practice problems. Well, maybe not with answers this time around. I mean, these are quite, I think I usually would call them practice questions. Okay. Yeah. So moving on, we talk about the first part now. What does factoring out a common factor mean? What does it really mean? So we see that to factor, I mean, this is a very general concept, even maybe starting from say junior high school or something. So to factor out a polynomial means to write it as a product of simpler expressions. When we factor out a common factor, we look for something that divides every term in the polynomial. We pull that common part out as a factor and we write the polynomial in this form. So the polynomial now becomes whatever is common, the common factor, multiplied by the remaining polynomial. Example, we have 12x plus 8. So 12 and 8 has 4 in have 4 in common. So we take out the 4 and the basic idea is just this. You have 12x plus 8. You want to factorize 12x plus 8. And you know that 12 and 8, they have 4 in common. So it's more like saying then that you have, so since you have taken the 4, it's more like you have 12x divided by 4 plus 8 divided by 4. So then you have 12x plus 8 to be the same thing as 4 into 12 divided by 4 is 3. So you have 3x plus 8 divided by 4, 2. So you have 4 into 3x plus 2 like that. That's the kind of thing we have here. So here 4 is a common factor of both 12x and 8. So we factored it out and we have the common factor is 4. The remaining polynomial is now 3x plus 2. So we move on to talk about greatest common factor for constants like numbers, and we talk about its definition. So for constant numbers, right, the greatest common factor, GCF, is the largest positive integer that divides all the coefficients, right? So example, if you have 18x squared, and 24x, and the coefficients are 18 and 24. And the greatest common factor of 18 and 24 is simply 6. That the greatest common factor, I mean, the easy way, nice way I learned to find the greatest common factor is this. So you have 18 and 24, right? 18 and 24. So you want to write both of them as a product of their prime number factors. So 18 is 2 times 9, for instance. 9 is 3 times 3. So this 18 is 2 times 3 times 3. And then 24 is 2 times 2. We have 12 left. That's another 2. Then we have 6. That's 2 again times 3. So 18 is 24 is 8 times 3. Now to get the greatest common factor, what do we do? Since we are talking about the greatest common factor, we go this way. 2 is here, and we have 3 here. Okay, so the greatest common factor will simply be to pick one of each, 2 times 3, and that is 6. That is the greatest common factor in that situation. And that is why we have this GCF of 18 and 24 to be 6 right here. Okay, so then we have GCF for constants, still under, okay, this is another point now. Yeah, so another point, GCF for constants now. So there are different methods for looking for the greatest common factor for constants. The first method is by listing the factors, okay? So to find the GCF of two integers by listing factors, so we have GCF of 18 and 24. So the factors of 18, the numbers that can perfectly divide 18 are 1, 2, 3, 6, 9, 18. For 24, they are 1, 2, 3, 4, 6, 8, 12, and 24. So the common factors are 1, so 1 is common, 2 is common, 3 is common, and 6 is common. But the greatest of them all is 6, So the greatest common factor is GCD of 18 by 24. That's simply 6. That is the greatest, that is the biggest of all the common factors like that. So the method I showed you on the other page, on the worksheet, is this other one. GCF for constant. And method 2 is by prime factorization, okay? So by prime factorization, another way is to use prime factorization, that is, you express each term as a product of its prime factors, okay? So 18 is 2 times 3 raised to power 2, just like what I showed on the other page. And then 24 is 2 raised to power 3 times 3. So we have at least 2 appearing in both cases. 2 raised to power 1 is common, and then 3 raised to power 3 is common. So we have 2 times 3, 6, just like what I showed previously. Okay, so and then this same concept can then be applied for variables. So starting with single variables, for instance, for powers of the same variable, the GCF is the lowest exponent easily. Okay, so if you have x raised to power 5 and x raised to power 2, so it's more like, well, if I'm going to be explicit about it, so I just have x raised to power 5, and this is x raised to power 2. X raised to power 5 is x times x times x times x times x. Okay, 1, 2, 3, 4, 5. And then x squared is simply x times x. So the greatest common factor will simply be, we have x here, we have x here. So we just take one each, x times x. And the greatest common factor is x squared, like that. So that's exactly what is playing out here. So for x cubed and x cubed, the greatest common factor is x cubed. X4 and x1, the greatest common factor is x1, which is simply x. So the reason is that the common factor must be a power of x that divides each term. So this corresponds to the smallest exponent present in all terms. So the greatest common factor has to divide both terms, right? And that is why we have the results we have. So talking about GCF for multiple variables now. So, previously we had talked about just variable X. But what if we have more than one variable, like we have 2 or more variables? So for terms with multiple variables, such as x raised to power a, y raised to power b, we compare each variable separately and take the lowest exponent that appears in each term. So find the greatest common factor of 12x cubed and 18x squared, y raised to power 5, right? So you deal with the coefficients and you deal with each variable one after the other. So for instance, for 12 and 18, the greatest common factor is simply 6. That's the biggest number that divides both 12 and 18. That's 6. 6 is that number. Then for this one, we have x cubed and x squared. So x squared, of course, just like what we've learned already. So x squared is the greatest common factor. And then for y squared and y raised to power 5, of course, y squared is it. So the greatest common factor is simply 6x squared, 6x squared, y squared. But if you want to be explicit, like I've always been doing, 12x cubed, y squared, all right? 12x cubed, y squared, and then you have 18x squared, y raised to power 5. Okay, 18x squared, y raised to power 5. So this is simply for 12. Now we have 2 times 2 times 3. That's 12. Then x, 1, 2, 3. For y, 1 and 2. And then for 18, that's 2 times 3. That's 6. Times another 3. That's 18. Times x, which is 2. And y, 1, 2, 3, 4, and 5. Okay. So the greatest common factor will simply be, so 2 is common, pick 2. 3 is common, pick 3. X is common, pick 1x. Then x is common, pick that x. What else do we have? We have y to be common, pick y. Okay. We have another y is common, pick y. So at the end of the day, GCF is 6x squared, y squared, just like we have, on that page. So 6x squared, y squared. So we go for greatest common factor or a polynomial. So here now we're talking about a combined idea. So that's the main thing. We're talking about polynomials here. So of course, but the things we've done previously is what is going to has led us up to this point. So to find the greatest common factor of a polynomial, first of all, find the greatest common factor of the coefficients. Therefore, each variable like x, y, etc., compare exponents and take the lowest exponent that appears in every term. Then multiply this together to get the monomial greatest common factor. Then factor the polynomial as polynomial equals polynomial greatest common factor multiplied by the remaining polynomial. So for instance, we have example 1. We want to factor out a greatest common factor here. So we have 18x cubed minus 24x squared. So the greatest common factor for coefficients is basically 6. We've got that a lot. So for variable x, we just have x squared. So the total greatest common factor is simply 6 times x squared. So we have 6x squared. So now to factor it, you have 18x cubed minus 24x squared equals 6x squared. Then 18 divided by 6, 3. X cubed divided by x squared, x. Then minus 24 divided by 6, 4. X squared times x divided by x squared, gone. Okay? So to be more explicit, 18x cubed, 24x squared, right? 18x cubed minus 24x squared. Okay, so we know that 6 and x squared are common. So it's more like we now have 18x cubed divided by 6x squared minus 24x squared all over 6x squared. So this cancels this. Then this cancels two of that, and we have one left. So we now have 6x squared into 18 over 6 is 3 minus 24 over, 3, and then we have x still. Then 24 over 6 is 4. So 6x squared into 3x minus 4, like that. So example 2 now, we have, for example 2, we have the greatest common factor with multiple variables. So for multiple variables, we go the same way. So we have 8x squared y cubed plus 12x cubed y squared. So we take the constant, the coefficients. So the greatest common factor of 8 for 8 and 12 is 4. 4 is the biggest number that divides both of them. Of course, 1 divide both, 2 divide both, and 4 divides both. And that's the biggest of them all. So we have 4. Therefore, x squared and x cubed, just pick x squared, the smallest exponent. For y cubed and y squared, just pick y squared, the smallest exponent. So the greatest common factor is 4x squared, y squared. Then divide each term by the GCF. So this 8x squared y cubed divided by the greatest common factor, you get 2y. The other one, so you divide by the GCF. That's 12x cubed y squared divided by 4x squared y squared. 12 over 4 is 3. X squared in x cubed, that's x. Y squared cancels x. Cancels y squared. So we have 8x squared y cubed plus 12x cubed y squared equals 4x squared y squared into 2y plus 3x, like that. Then we can talk about extraction of monomial factors. I'm talking about the general procedure, right? A monomial factor is a single term factor like 5x minus 3a squared b, 2x squared y. So it's a monomial, like if you look at previous videos where we talked about monomials now. So that's basically the idea. So a monomial is simply a term in a polynomial, it's one of the terms taken with its sign. So to factor out a monomial from a polynomial, given a polynomial like ax raised power n plus bx raised power n plus all of that, so you follow these steps. First of all, write each term clearly, separating coefficients and variables, very important. Then find the GCF of the coefficient. Then for each variable, look at its exponent in each term. Take the smallest exponent present in every term. That's what we've been doing. Then multiply this together to form the monomial greatest common factor, right? Divide each term by this monomial GCF and write the results in parentheses. That's exactly what I've been doing all along. So polynomial now is equal to the monomial greatest common factor multiplied by whatever is left in the parentheses. Okay. So we have example 3 in that regard. So first of all, we have extraction of a monomial factor. So from 15x cubed y squared minus 20x squared y raised by 4 plus 5x raised by 4 y squared now. So first of all, the coefficients are 15 minus 20. Well, you can leave the sign alone. 15, 20, and 5. So the greatest common factor of 15, 20, and 5 is simply 5, right? So that's the biggest number that divides 3 of them. Then for the x's now, x cubed, x squared, x4, we take x squared. Y squared, y4, y squared, we take y squared. So the greatest common factor is 5x squared, y squared. So divide 15x cubed y squared by 5x squared, y squared. So 15 over 5 is 3. Y squared cancels out. X cubed over x squared, that's x. Then minus 20 x squared y4 over 5x squared y squared. So we have x squared cancelling out. Minus 20 over 5 is minus 4. Then y4, y squared. So two of this will cancel 2 of this. So we have 2 of y's left. And then here, 5 over 5 cancels out, y squared cancels out, then we have x squared left. So at the end of the day, we get that this expression is equal to 5x squared y squared into 3x minus 4y squared plus x squared. So optionally, we can rearrange terms in standard order. So you can then say 5x squared y squared plus x squared plus 3x minus 4y squared. So you start with all the x's and then you move on like that. Okay, so let's talk about sign choices and special cases. In case we have like all terms, when all terms are negative. Well, now negative signs can be very problematic if you are not careful, because I remember losing the math prize in first year of senior high school because I made a mistake plotting a graph with using minus sign in a graph when I should have used plus. Okay. So when you have minus, you have to be extra careful. And one of the things you can do is there's a way you can remove the minus carefully so that you can concentrate on other things and avoid the trouble minus can cause you. Okay. So when all terms are negative, it is often convenient to factor out a negative greatest common factor. Very important. You can factor out a positive negative factor, but a positive factor, but it's better to factor out negative so that you can concentrate what exactly you want to do. Okay, so for the coefficient 6 and 9 now, the greatest common factor is 3 for sure. For x squared and x, the GCF is x. So common factor, it could actually be 3x, but both terms are negative. Since both terms are negative, it is safer to take the minus out once and for all so you can concentrate. Because normally if you just take out 3x, so you still have minus 2x minus 3. But if you take a minus 3x, so it's safe. Minus 3x is outside, so you can focus. So it's easier to work with plus than to work with minus as much as possible. So by factorizing on minus 3x, you have uh you have reduced your stress, and then you can focus on this. So this is just 2x plus 3. Thankfully, there's nothing else to do after that. So you have minus 3x times 2x, of course, is minus 6x squared. Minus 3x times 3 is minus 9x. So to be sure that what we have done is okay. Now we have some special cases. For instance, no common variable. What if there's no common variable? What do you do? So sometimes the terms share only a numerical factor, not a variable. What do you do? Focus on the number. So for coefficients now, we have GCD of 10 and 15. That's, of course, 5. That's the greatest common factor for 10 and 15. That's 5. And for the variables, now one term has x squared, the other has y. No common variable. So the GCF is simply the 5. That's all. So you have 10x squared plus 15y equals 5 into 10 over 5. That's 2x squared. And 15 over 5, that's 3. And with the y, like that. Okay? So these are basic, these are more like high school stuff. That's why I'm really just breezing through. So special case, what about when the greatest common factor is simply 1? What happens? So if the only factor is 1, the polynomial is not factorized, it's not factorable by a non-trivial monomial GCF. Example, you have 3x squared plus 5x plus 7. So the coefficients are 3, 5, and 7. So the greatest common factor of 3, 5, and 7 is simply 1. Okay, so the variables, not all terms even have x, so there's nothing common at all. So there's no non-trivial monomial to factor out. So we say the polynomial is already simplified. So this is the simplest form of this polynomial with respect to the greatest common factor factoring. Of course, there are other kinds of factoring we can do. Like this is quadratic, for instance, and that's why there's another video that talks about factorizing quadratics, right? So you want to watch out for that. So we can still factorize this using all those other things. But since you're just talking about constants and monomials, we can't, it is basic enough, right? So 7.1 to checking by distributing back. So sometimes when you factorize, you want to be sure if you are really correct. So, and the way to do that is what you have factorized, can you try to expand it and see if you get the same result that you started with? So after factoring, you should check your result by distributing back the factor to see if you recover the original polynomial. Suppose we have P of x equals GCF times Q of x, right? The greatest common factor times whatever is left of the polynomial. To check, multiply the GCF across the term in Q of x, simplify the expression, confirm that the result equals the original P of x. We are going to do that with maybe one of two of the practice questions later on. Okay, we even have that here. Checking the factorization. So we previously factored 18x cubed minus 24x squared to be 6x squared into 3x minus 4, right? So if you want to check if what you did is correct by multiplying this again to see if you get back what you had. So checking by distribution, you have 6x squared times 3x. So 6x squared times 3x, that's 18x cubed. Then 6x squared times minus 4. That's minus 24x. So that's 6x squared times this minus 4, you have minus 24x squared. So now you're back at where you started. So we are good. So the factorization that you did was actually correct. So what if you want to check with negative greatest common factor? So factor that and then check. We have minus 12x squared y plus 18xy squared. So the coefficients are 12 and 18. So the greatest common divisor or the greatest common factor is 6. Right? So for the variables x, for x, you have x squared and x raised to power 1. So you take x. You have y and y squared. You take just y. So we then factor out minus 6xy. So that's minus 6xy into, so minus 12 divided by minus 6, that's 2. And then xy, 1x cancels, y is gone. We have 2x. Then carefully now, you have plus 18. 18 divided by minus 6 is minus 3. Carefully. Okay, so y cancels 1y, so we have an x cancels us, so we have 3y here. So you now check to see if what you've done is fine. So minus 3xy plus, times 2x is minus 12x squared y. That's what exactly you have here. Then minus 6xy times minus 3y. That's basically minus and minus is plus. So that's plus 18xy squared. So we recover the original polynomial, so the factorization is correct. So sometimes if you're in doubt, if what you have done is correct or not, you may want to to distribute the GCF over what is left and then see if you're right or not. So what I'm just going to do here, I'll do this. We have 10 questions here. So I'll take care of, okay, the first one is easy. So I'll take care of questions 3 and 10. And that will be all for this particular video, questions 3 and 10. So questions 3 and 10. Let me go to the worksheet. Yeah, so the deal here is to, for question 3, factor out the greatest common monomial from each polynomial. So for question 3 now, we have minus 30 x squared y plus 45 xy squared, okay, minus 15 xy, right? So minus 30 x squared y plus 45 xy squared minus 15 xy. So with this now, since we have done this a lot, what I'm just simply going to do is, so you can see minus, there's minus here, there's no minus here, but there's minus here. So because this one is even starting with minus, so maybe you can either rearrange or take out the minus. So first of all, I'm going to put minus outside. Then look at 30, 45, and 15. The greatest common factor is 15, as you can see. 15 is the biggest number that can divide 3 of them, for sure. So you have, then to come to x squared, x, and x. So the smallest exponent is x raised to power 1. So we go with that. So this is y squared, and y. So the smallest is y. So, and we have that into minus 30 divided by minus 15. That is simply 2. X cancels 1 x here. So we have x. Y is gone. Then now, be careful. 45, right? Divided by minus 15 should be minus 3 because 3 times 15 is 45, but plus divided by minus is minus, okay? So x cancels x, y squared cancels y, so we have 1y left. And finally, minus 15 divided by minus 15 is plus, so you want to be careful. So once you take minus outside, all the signs change. So minus changes to plus here, then plus changes to minus here, and minus changes to plus here. So 15 cancels 15. So you just have 1 in short. 15 cancels 15. X cancels X. Y cancels Y. So everything is 1. So we have this now. But you may want to check to be sure if what you did is right. So to check now, okay, you want to check. So you have minus 15xy times 2x. So minus 15 times 2 is minus 30. X times X is X squared. And we have Y. Minus 15xy times minus 3y. Minus times minus is plus. Then 15 times 3 is 45. X, so that's 45. Okay, there's only one x here. Then y times y is y squared. And lastly, minus 15 times 1, that's minus 15 xy. And that's it. Okay, so that means that's the same as what we started with. So we are good to go. That was question 3 right there. So let's go for question 10 that I also promised to do. So for question 10, or should I do 10? Okay, that's fine. Question 10 now. We have minus 20 m4 n squared minus 30 m cubed n cubed plus 10 m squared n squared. Okay, so again, this is the same thing as looking at the numbers now. So because minus is starting it, I also take out minus because it's better not to have minus starting if possible. Okay, so 10 is the greatest common factor of 20, 30, and 10, right? So I'll just take out minus 10 into, like I said, the signs will automatically change once you take minus out. So minus here becomes plus for the first one. For the second one, minus becomes plus. For the third one, plus becomes minus. Okay, so 20 divided by 10, that is 2. Okay, okay, I guess I was too fast there. Uh, Let me carefully do this. Okay, so like I said, we have plus for the first, second will be plus again, third will be minus, like that. But then for m raised to power 4, m raised to power 3, m raised to power 2, you take the smallest, that's m raised to power 2. For n raised to power 2, n raised to power 3, n raised to power 2, that is also n raised to power 2. Okay, so if you now factorize 20, minus 20 divided by minus 10, that is simply 2. Okay, m raised to power 4, m raised to power 2, 2m will cancel 2m, so you have 2m's left. N squared and n squared will be gone. And then for this other one, now we have minus 30 divided by 10, that is plus 3. So m cubed, m squared, 2m will cancel 1, will cancel 2, we have 1 left. Then n squared, n cubed, 2n will cancel 2n, so we have 1n left. And lastly, plus 10 divided by minus 10, that will be minus, like we've already taken care of. M squared divided by m squared, 1. N squared divided by n squared, 1. So we basically have that result. So with that, we are good with that. So you want to try the other questions. And with that, I come to the end of this very interesting video about factoring out common factors in polynomials. I mean, it's basic. It's more of a junior high school kind of maths, but it's fine. I think it's important also to take care of this nitty-gritty to avoid any confusion that might arise in anybody's mind. Thank you so much for listening to this. If you have subscribed already, I thank you very much. If you have not, why not go ahead and subscribe right away and hit the notification bell also so you can always get alerted each time a new video is uploaded. Okay. Having done that, you can become a member of the channel for sure by clicking on join, and you see 3 levels of membership with special privileges. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing math right. Bye.